Energy. It plays a huge role in pushing us forward and making our lives easier. However, while energy does help us out a lot, it does come with a few catches, the two most prominent being abundance and safety, which have raised quite a few number of questions, making us ask, is there an alternative? Imagine if I told you there was an energy source out there, which was not only available in large quantities, but safely produced energy. You'd think that I was joking, but in reality, I just gave you a perfect description of helium-3. But what really is this helium-3 and how does it work? Helium-3 is an isotope, or simply put, one of the many versions of the element helium. It is also non-toxic and non-radioactive, which is what makes it safer to work with than nuclear energy. Now let's see how nature manufactures helium-3. One of the primary ways helium-3 is created is through radioactive decay. For example, let's take a look at tritium. Tritium is a radioactive isotope of hydrogen, which is formed from events like cosmic rays colliding with isotopes like nitrogen-14 or hydrogen-2 to create tritium and carbon-12. While the carbon-12 nucleus is stable and satisfied, the tritium nucleus isn't, so it fixes this by undergoing further decay and releases one electron and one antineutrino, leaving behind a stable helium-3 nucleus. But how do we even utilize the energy helium-3 has to offer us? Well, one common way is to make helium-3 undergo nuclear fusion with the help of deuterium, a stable isotope of hydrogen. When we fuse these two together, we get helium-4, along with a proton ejected from the fusion reaction. Also, we get a lot of energy. How much exactly? Well, 1 kilogram of helium-3 gives us about 19 megawatt years of energy. By the way, for those of you who don't know, a watt year is, and I quote, the measure of energy by 1 watt in 1 year. But more astounding than that is the amount of energy required to burn helium-3, which ranges from 10 kiloelectrovolts to 200 kiloelectron volts. Now let's take a look at the other wonderful aspect of this gift from nature, supply. When it comes to supply, helium-3 can be found on Earth, however not in amounts we would consider adequate. You see, our tremendous amount of helium-3 is not found down in the ground, but rather up in the sky. Yup, our moon is a cornucopia of helium-3. But how is this? The simple answer is solar winds containing helium-3. For those of you who don't know what solar winds are, I covered them in my Mars video. Anyways, solar winds containing concentrations of helium-3 have bathed the moon in the substance. However, the helium-3 wasn't scattered across the moon evenly, with some regions containing more than others, especially with Lunar Maria containing more than half the helium-3 on the moon. Moreover, meteorite collisions have resulted in the helium-3 being buried a couple of meters deep in the lunar soil, leaving us with the question of how do we extract it? Now, this is one of the obstacles which stands in the way of us obtaining helium-3. However, we have devised one solution, which includes heating up the lunar soil to about 600 degrees Celsius or 1,112 degrees Fahrenheit, which NASA plans to do with their project Lunar Miner Mark II, a sophisticated mining robot which can excavate lunar soil containing helium-3 and use the power of solar energy to heat it up and extract the mineral. We haven't completed Mark yet, but when we do, we can marvel at the fact that the helium-3 on the moon could meet our energy needs for the next, say, 10,000 to 100,000 years. So, at the end of the day, the answer is still unclear. We still have many obstacles which we have to overcome, so be sure to stay tuned for part 2, in which we continue our journey to a helium-3 powered future. I hope you enjoyed this. If you did, then be sure to leave a like and subscribe for more science videos. Also, happy holidays.